I welcome all of you once again to the last part of this outline of class imbalance. This video is part 4, so let's move towards the lecture. So far we have seen two types of techniques, and today we will see the third one. This strategy samples the minority or majority class more or less frequently. When working with an imbalanced dataset, we can use replacement to oversample the minority class. This method is known as oversampling, the practice of randomly eliminating rows from the majority class in order to align them with the minority class is known as undersampling. After sampling the data, a balanced dataset for both the majority and minority classes can be obtained. As a result, we may anticipate that the classifier will treat all classes equally when the dataset's two classes have an equivalent number of records. So today we will see random oversampling. Python module. There have been a few suggesting more sophisticated resampling techniques in the scientific literature. When oversampling, we can introduce subtle adjustments into the minority class records rather than exact reproductions in order to produce more diversified synthetic samples. Let's put some of these resampling techniques to use by using the Python package Imbalance Learn or IMBLearn. It is compatible with scikit-learn and a part of the scikit-learn contrib projects. So first of all, it's quite essential to get familiar with the term random undersampling with IMBLearn. The creation of new samples from the minority classes is one strategy for overcoming imbalanced data. The most simplistic approach is to replace the current samples with the new ones obtaining through random sampling. Such a method is provided by the random oversampler. So how random oversampling works? Import the required library first of all, then fit the predictor and the target variable. Then check the shape before fitting and after fitting. So here is a diagram of random oversampling. We can see that we have created samples from the minority class. And after resampling, these synthetic samples are equal to number of majority class. So let's move towards the current example, which is of credit card fraud detection. Let's implement. First of all, I will open Jupyter Notebook. Then I will open the folder of data size, then class imbalance, and from here I will create a new notebook. First of all, I will rename the notebook and I will say class imbalance part 4 and rename it. Now at first, I will use Markdown and I will say import libraries, which is the most essential part before using the functions of libraries. So I will say import numpy as np, import pandas as pd, and then I will say from imblearn dot oversampling import random oversampler and then run it. Now I will use another markdown and say read CSV for reading the CSV file. So first of all, I would say transactions equals to pd dot read csv. The name of file is transactions dot csv, which is actually a comma separated file. As the dataset is too large, so it may take a while to read or load the dataset into the notebook. Now, I will say transactions dot head and see the first 5 rows. As you can see, our target variable is here, and all of these are predictor or the feature variables. So I will generate a summary of datasets to see the data types of each of the column. All right. So we have some integers, objects, and floats. All right. So before using the random or sampler, I will have to split the dataset. I will say split, and I will split the dataset into predictor and target variable. So for predictor, I will say transactions dot draw, and I will say keep all of the columns and just drop the target variable, and axis equals to 1. Now for y, I will say transactions and just keep the target variable in y. Now I will use markdown for random over sampling and then run it. So first of all, I will have to import another library. I will say from collections import counter to see the shape before sampling and after sampling. Now, first of all, I will create an instance of the class by saying ROS, which represents the variable random over sampling, and I will say random over sampler, and I will pass the parameter of random state and the value 42. Then I will say rows dot fit resample and resample the variable of x and y and store them in x rows and y rows. Let's run it. Now here I will say print, and I will say the shape of original dataset is, and the shape is counter, and I will pass y. Now similarly, I will say print the shape of dataset after sampling is counter y rows. Since we can see that the previous cell is executed, so it means that now we can run this cell. The shape of original dataset is this. As you can see that 0 has this value, which is the majority class. and one has this value, which is the minority class. And the shape of dataset after resampling is this. As you can see that the dataset is resampled, and now the minority class has an equal number of rows as the majority class. So now let's go back to slides. Now it's time to see the advantages and disadvantages of random oversampling. So in advantage, we can see that in comparison to undersampling, this approach results in no information loss as we don't delete the number of rows. It performs better than undersampling. Now the disadvantage is, as a result of replicating occurrences from minority classes, the chance of overfitting increases. Conclusion. To sum up, we have seen a variety of methods for handling class imbalance in a dataset so far. When dealing with imbalanced data, there are actually a lot of approaches to attempt. You should now have a better understanding of a few methods for handling imbalanced datasets. So here is your homework. As you can see that I have placed the link of dataset here. And this is your first task. Do some exploratory data analysis. Then find out the counts for each class in target variable. Then make sure the dataset is balanced by choosing random oversampling. So this is the end of today's video and of this outline. See you next time.